Hey, what's up, everybody? This is Ned Bellavance, and I'm going to be walking you through building Azure infrastructure using Terraform and GitHub Actions. So let's dive right in. All right, so to get things started, I'm going to talk a little bit about GitHub Actions. If you're not familiar with GitHub Actions, here's a little bit of background for you. First of all, GitHub Actions are a way to automate some jobs and steps in a process when something happens with your repository. And I know that sounds vague, but it's because GitHub Actions is kind of powerful. So it starts out vague and then gets specific. So where are these actions stored? The actions that you want to define are actually stored in the same repository, Azure code. So when you check in some new code, you can also update the actions, and then GitHub finds that actions file. And within that actions file, you define one or more jobs that you want GitHub to run when certain events take place. So you have these jobs, they basically run inside of containers, either predefined containers that are available from the marketplace of GitHub Actions, or you can create your own customized containers that will run as well. And why do these things happen? When do actions kick off? They kick off when an event happens in that repository. That could be a push to the repository, it could be a pull request. There's different options you can select for when GitHub Actions should kick off. And then within the jobs, you can define which of those subset of events apply to specific steps in the job. And we'll see how that works in a moment. So that is GitHub Actions as quickly as I can define it. Let's get into the world of Terraform. Now, if you haven't used Terraform before, there's no way I can sum up everything it does within the time allotted to me, but I do want to stress a few things about Terraform. And if you're not familiar, you can go and do a little reading if that is helpful to you. Basically, Terraform at its core is there to automate infrastructure as code with a state behind that. And that state is the relationship between what's defined in your infrastructure as code config and what's actually deployed in the real world. So that's how Terraform kind of keeps track of things. If you think about when you're deploying an ARM template to Azure, once that template is deployed, there's no real relationship between the template and what's actually been deployed. You can kind of do an incremental update, but it's not great. Terraform gets that out of the way by actually tracking the relationship between your config and what's been deployed. Now, that config is written in HashiCorp configuration language, which is a lot more human readable than JSON and not whitespace dependent like YAML. So it's a nice mix between the two. And because it's defined in code, you can store that code in a repository, say a GitHub repository. So now we can combine our love of Terraform and our love of GitHub and GitHub Actions to reliably deploy our infrastructure as code on Microsoft Azure. Now, I'm going to do this all in a demonstration today, and I'm going to need to set up a few resources ahead of time to be successful. And if you want to follow along, you can do this as well. So what resources do we need to create ahead of time to get this whole thing to implement properly? The first thing we need is a service principal on Microsoft Azure. Why do we need that? Well, we're going to be deploying resources to Azure, and in order to deploy those resources, we're going to need permissions. And so we can give a service principal the appropriate permissions to create and destroy resources in a subscription. That's what we're going to do. In order to store Terraform's state, one of the options for state storage is to use an Azure storage account, some blob storage. So we're going to create an Azure storage account to store our remote state data. And then finally, we are going to need to generate some secrets in our GitHub repository that GitHub Actions can reference when it's doing its run, stuff like the service principal information, its password, and its client ID. All of that needs to go into secrets so it's referenceable when Actions runs. So we're going to create those 3 demo resources. Why don't we jump over to Visual Studio Code, and I'll walk you through the process. Okay, here we are in Visual Studio Code, and this is my preferred code editor. You can use whatever you'd prefer if you're trying to follow along at home. All of these files are available in a GitHub repository. It's the same one that we're going to be using for GitHub Actions. So we'll see where it is in a moment. Before we do that, though, there's a little prep we have to do to get our resources deployed. And that information is in the remote setup folder within the repository. Now, the first thing we need to do is log in with some credentials to Azure, and we're going to use the Azure CLI to do that login. So we're simply going to run AZ login. Go ahead and copy that and paste it down here. And that will open up a browser window. I will verify that it's me that wants to log in. I've logged in, and now we can go back to Visual Studio Code. It'll go through all my subscriptions, and I have to pick which subscription I want. And the subscription I want, let me go ahead and copy this command. This is how you select a subscription. AZ account set dash H dash S, and the subscription name that I'm going to use is MAS. So now I've set which subscription I want to use. Terraform is aware of the credentials helper for the Azure CLI. So if you don't give it any credentials to use with Azure, it'll just use the ones that you have stored in your AZ CLI creds. So that's the easiest way to do it. Now we're going to go into the remote setup folder. There we go. And we also need to specify a GitHub token because it can use our Azure CLI credentials to talk to Azure, but it needs something it can use to talk to GitHub, and that's going to be a GitHub token. And since we're using PowerShell, we'll set our environment variable this way. If you're using the Bash shell, you can set it the other way. That's fine. Let me go ahead and grab that token that I already created for myself. Grab that, and I'm going to go ahead and delete token value and paste in the proper token value. And don't worry if you're watching this, I've already invalidated the token, so I don't have to, obscure it. It's fine. It's invalidated. No one can use it now. Anyway. All right, so now that we have all that information, we can go through the setup process. So let's talk about what's in that remote setup real quickly. I'll go ahead and open up the file. And basically, we have to define three providers that we're working with because we're working with Azure RM to create the storage account. We're working with Azure AD to create our service principal. And we're working with GitHub to create those secrets that are going to be stored in the repository. And up here, we're defining what the repository name is. So if you are following along and you've just forked the existing repository, this should work for you. If you changed the name or are creating your own from scratch, you're going to have to change this value either by changing the default string or submitting a different value when you run Terraform. Now let's scroll down here. In the locals, we define a resource group name, a storage account name, and a service principal name. And I do use a random integer for that, so it'll be globally unique, so we won't have any kind of collisions, especially for the storage account name. All right, and then we don't have to go through this whole thing. You can go through it at your leisure, but basically, like I said, we create that service principal in Azure AD, we create the storage account in Azure, and then down here, we create the secrets in GitHub that will be used by GitHub Actions. So let's go back to the commands that we're going to run, and we'll go ahead and run Terraform init. And this will initialize our Terraform configuration, download the providers it needs, the ones we referenced in our config. And if we were using modules, I don't think I am, but if we are using modules, those would be downloaded as well. So that should run relatively quickly. And then we can run our Terraform plan and our Terraform apply. That's the general procedure for doing that. So we'll go ahead and run Terraform plan now. I'll paste that down here, and this will figure out what resources it needs to create in the real world to match what you have in your configuration. So this is the cool part. This is where the rubber meets the road, right? Once the plan is complete, then we will move on to the apply stage, which actually creates the resources that it just told us it was going to do in the plan phase. All right, so there we go. That's everything that it's going to create. So it's going to create 15 new things. We'll go ahead and run Terraform apply now. And while that is applying in the background, let's go ahead and talk about what is going to happen in our GitHub workflow. All right, back to the presentation. What are we actually trying to do in our GitHub workflow, in our GitHub actions that we're defining? Well, basically, we want to look for two events that could happen when you're working with this repository. And those events are a push to the remote repository, the GitHub repository, or a pull request that's been generated on that repository. And if you think about your general code workflow, usually what you see is when you want to add a feature or make a change, you create a new branch, and then you push an update to that branch. And then once you've reviewed that update and it's gone through some sort of checking process, at that point, you would create a pull request to merge it to the main branch or whatever branch you are working on that you want to add that feature to. So when that first push comes in or a pull request comes in, the first thing we want to do is look at the code that we've submitted, make sure that it's formatted properly and that it's syntactically valid. And that's what these two commands in the world of Terraform do. FMT checks the formatting, and if it returns anything but an exit code of 0, then the formatting needs to be fixed. And validate, same thing. It will initialize the config, get all the providers, and then run through the validate process to make sure that the configuration is syntactically valid. Doesn't mean it's going to run perfectly, but at least you know the code makes sense. Now, once that process is complete, now we have a fork. We have two different potential things that could be happening here. If this is a pull request, so I've checked in my branch and now I want to, it's gone through this format and validate, that all checks out. Now I'm creating a pull request where I want to merge this to main. Before I do that, I want to know what changes would happen if that pull request was merged. So we are going to run a plan, a Terraform plan like we just saw that tells us what are the changes? What is it going to do? And then we'll take the output of that plan and we'll put it as a comment in the pull request. In that way, someone who's reviewing the pull request can look at that plan and go, yep, thumbs up, all looks good. You're creating things that I want created, or thumbs down, no, not going to merge this. You need to make changes and rerun the CI process. The other option would be push on main. So if this is a push, which is basically what a merge is, it's a push to the main branch or whatever branch you're merging to. When that happens, I want you to take the same code that was approved and I want you to apply that configuration to my actual environment. In our case, we're creating an Azure virtual network. So these are the two different branches that happen within our GitHub Actions. So let's go back to VS Code and explore what's happening in our Actions file. All right, we're back in Visual Studio Code, and you can see our initial remote setup has completed successfully. It created that storage account and the service principal and added those GitHub secrets. And so that's awesome. That's everything we need. And it also outputs the secrets in case you needed them. But let's go over, because we need to understand what we're doing with these secrets. There is a folder here called .github workflows. And in there, there's a terraform.yaml file. This workflows folder is where you're going to put any of your GitHub Actions configurations. So let's go ahead and open up that file and we'll scroll all the way up to the top. This is the code that we're working with. And the first thing we do is name it. What's the name of our action? We're calling this Terraform, keeping it simple, right? And then the on statement that we have here, this defines what events we're looking for. And remember, we're looking for a push, whether that's to the main branch or to any of the other branches, and we're looking for a pull request. Those are the two events that we're concerned with. Okay, now for the environment variable, this is a general environment variable. I'm turning the TF logging to info to just give more verbose information of what's happening with Terraform. That will help with troubleshooting later if we do run into an issue. Now under jobs, now we're getting into the meat of things. Jobs are where you define one or more jobs that you want to run as part of this actions. And we are going to create a job called Terraform. And the name, we're calling it Terraform, runs on Ubuntu latest. So this is the container that you want to run this action on. Okay, awesome. Now we know which container it's running. It's the latest of Ubuntu. Then we can set some defaults that will be consistent across all of the actions. For our defaults, we want to use the bash shell for all of our commands, and we want to set the working directory to main. That's where our main Terraform files are. They're in this main directory, so that is what we're going to be using here. And now we set up our steps. What should happen in this job? Well, the first thing it's going to do is check out the code from the repository. That kind of makes sense. It's going to need that code to do anything else. And then the next step is to set up Terraform. This is where it basically gets the Terraform bits and adds them to the container. And the uses says which thing in the GitHub Actions library do you want to use for this? So we're using setup Terraform v1. And really all this does is download the Terraform executable and set up a few things. And we can specify exactly which Terraform version we want. We're going with 13.5 in this case. If 14 comes out, it might be out by the time you're watching this. You could update this to 14. I don't think it'll break anything. 14 is not a big change. Okay, so now that we've set up Terraform, it's ready to go. We always know that the first thing we need to do with Terraform is initialize Terraform. So we're going to run a Terraform init step. So we're calling this Terraform init, and we're also giving it this ID field. The ID field lets us refer to this step from another step further on down in the line. And we're going to do that for all the steps here on out, is give them their own unique ID so we can refer back to them. we're also passing it to environment variables, and these are stored in the GitHub secrets. In order to successfully run an init, we need to pass it the SAS token. That's our token for accessing the storage account we're going to store our state data in, and the name of that storage account. We're setting those as environment variables, and then we can run Terraform init and specify a backend configuration using the storage account that is named in that environment variable. And because we have the ARM SAS token environment variable, Terraform will use that to authenticate to the storage account. So that takes care of our initialization. We should be good from there. What's the next thing we wanted to do? Well, in all cases, push or pull request, we wanted to verify the formatting on the Terraform configuration. So what we'll do is we will run the command terraform fmt-check, and that will check to make sure that the format is correct. It's not going to change anything about the file. It just checks the formatting. And if it doesn't return a 0, it fails and we drop out of the check. Next thing it's going to do is run Terraform validate. So it's going to run Terraform validate no color, because we don't really need color. We're not watching the output. And that will validate that the configuration is syntactically good. Okay, now if we've gotten to that point, we may or may not want to run a Terraform plan. If you remember, if this is a pull request and we want to check to see what changes are going to happen, we're going to run a pull request for that. Okay, so let's assume this is a pull request. The ID here is plan, and we're going to pass it all the environment variables it needs to run a successful plan. So in addition to the storage account information, it's also going to need our service principal information. And for that, it needs the client ID, the client secret, the tenant ID. This is the Azure AD tenant where that service principal exists. And the subscription ID is the subscription that we're going to be working with in this case. Okay, so we set all that information in GitHub secrets when we set up our initial remote setup. And we also need the SAS token again. So we're going to submit all that information. And then lastly, we're doing this if statement here. And the if statement basically takes a look at the event name. And if it's pull request, we're going to run this step. If it's not, it's going to skip the plan test. That's how we check whether or not this is a pull request. If it is a pull request, we are going to run Terraform plan. Now, what do we do with that information? Well, that's where we get to the next step, which is add a comment to the pull request if it is a pull request after we've run plan. And this is a little bit different. This is a Git action defined by GitHub script GitHub script v3. And again, we're checking to make sure that this is in fact a pull request. Now, the information that we want is from the standard output in our step plan. So we're referring to that here, steps.plan. So plan refers back to the ID of the Terraform plan. And then the outputs, standard out. So we want to take the standard out and store that in an environment variable called plan. And now we are going to run a script here that we define inline that basically takes a look at what happened in the various steps. So we're going to look at what was the outcome of our format step, what was the outcome of our init step, what happened when we tried to validate it, and then lastly, what happened when we tried to run the plan. We'll get the outcome, and then we'll actually print out the entire plan by doing process.environment.plan. That'll print out all the details of the plan, and that'll all be added as a comment with this script down here, github.issues create comment. It's going to create that as a comment in our pull request, and we'll be able to review it. That's awesome, right? And then last but not least, we have Terraform apply. So if this is referring to the main branch, that's my main branch that I use, and this is an event of push type, we're pushing to main, which basically means we're merging a pull request. You could push directly to main if you wanted to, but you know you're not supposed to do that, right? If that is all the case, we're going to set the same environment variables we did before, but this time we're going to run Terraform apply and generate our infrastructure. So that's everything that's in our actions file. I know there's a lot there. It's a lot to go over. That's why you have this available to you to check out after you watch this, or if you're following along, you know, you can always pause and come back to it. All right, so how do we get this thing to kick off? Well, think about what we need to do. We need to create a branch. we need to make a change and commit and push that. All right, so we can do that now. We are in the remote setup, so we'll go up by one directory, and we're going to do git checkout -b to create a branch as part of checkout, and we can call this one, we'll call it elves. All right, we've switched to a new branch called elves, but we haven't made any changes to commit yet. So let's go into our main configuration. Here's our main configuration, and let's just change a value in here somewhere. We'll change the subnet names to subnet 0, 1, 2, and 2, because we should start our numbering with 0, right? We'll go ahead and save that change. That now shows up as a change, and we can now enter in here subnet change, and we'll go ahead and commit that change, and now we will push that change, and it'll let us know there's no upstream branch for this. It's automatically going to create a new branch up in our GitHub repository for that. And now we can go over to the browser and see what happens with GitHub Actions there. All right, now here we go. We're in our GitHub repository, and we're going to go to the Actions tab. Actually, before we do that, we'll go over to Settings, and in Settings, we'll go into Secrets. This is where the secrets get set. So all of these secrets were set by our initial Terraform configuration, and so they're all available for Actions to use. Now let's go over to Actions, and we should see there's a new one that kicked off. There's a bunch of failed ones. That's fine. Don't worry about those. I did a lot of testing with this before I tried to record the demo. Let's go into subnet change, and we can see that it already worked through one completed job. Take a look at the steps it went through. So it ran through initialization, and it went fine. It went through format, it went through validate. Both of those returned a successful thumbs up. It's all good. So we didn't have any failures here. Now that we're green, we know that at the very least, our file is formatted properly and that it is internally consistent in terms of syntax. Now we can go back to our main code tab, and we can start a pull request for this. So we'll go ahead and click on compare and pull request, and we're just gonna write up something simple. Subnet numbering change. That's what we'll call it. All right, so we're doing a subnet numbering change, and go ahead and click on create pull request. Now that we've created a pull request, this is going to kick off a separate actions. So we should see that pop up. There we go. So now it already went through this first one, the Terraform push steps. It already checked the stuff in that. So now it's running the next action is what happens when there's a pull request. And if we go to actions here, we can see it's already running the subnet change action, and we can go and click on here to actually watch it go through the entire process and see all the things that it is outputting to the screen, basically. So our Terraform plan was successful, and sometimes this doesn't show up until a little bit for whatever reason, but it also did successfully add the plan comment. So if we go back to our pull request and take a look at our open pull request, down in here, GitHub Actions added this comment, and we can see our format is good. Our initialization was successful, our validation was successful, and our plan was successful. And now it puts a little thing in here that shows the full output of our plan, and it lets us know it's going to create a resource group. It's going to create a 1, 2, 3 subnets, all as part of a virtual network. So that's everything in there. We are feeling pretty good about this. It passed all of our checks. So now we can actually merge our pull request into main. So let's go ahead and do that. We'll click on merge pull request and confirm the merge. Once that merge goes in, it's now going to kick off a new GitHub action because we have pushed to main. So we can go back into actions here. We can see merge pull request has kicked off a new action. And if we go into that action, we'll see it go straight from validate, I believe, down to Terraform apply. All right, there we go. It's in Terraform apply now. So it's now going out creating that resource group VNet and the subnets in the VNet. Now that should go pretty quickly because, well, let's face it, there's not that much to do. If we go back to our pull request, we can see that our pull request is closed. If we take a look at our subnet change pull request, generally speaking, you want to delete the branch that you just merged in. So I'll go ahead and delete the elves branch. That's gone. Okay. Now, the next step of this, well, let's go back to actions and just make sure that actions went through okay. Looks like actions went through okay. Let's go ahead and open up the portal and just validate that our virtual network is there. Okay, here we are in the portal. Let's go into, we can just look at all of our VNets here. There we go. There's our virtual networks. Here's a virtual network called Gumdrops Demo. That is, in fact, the name of the virtual network that's in the configuration. And if we go in there, we can see that the cost center is Elves, Environments North Pole, and the project is Festive Tech Calendar 2020. So it absolutely created our virtual network. We can look at our subnets and just validate that it's subnet 0, 1, and 2. That's good to know. All right, so what's the next step in this? Let's say that we realize we set the cost center wrong. Let's go back to our Visual Studio. All right, we're back in Visual Studio Code. And let's say we realized, hey, the cost center isn't elves, it's those pesky reindeer. The reindeer are the cost center. Oh, geez. Now, before I save this change, I'm going to go back to main. So I'll do git checkout. Oh, I can type checkout main. Awesome. And I'm behind because some commits have been made. So I'll go ahead and run git pull to get myself up to date. All right. And now I'm going to create a new branch called reindeer. So I'll do git checkout -b reindeer. Okay. We've switched to a new branch called reindeer. Now I'm going to go ahead and save this file. I've changed the cost center to reindeer. I can go ahead and put that in the commit message. Reindeer update. I'll go ahead and commit that and now push that to the GitHub repository. And it's going to create a new branch for that. And because I pushed something new, that will kick off the first of the GitHub actions. So let's go back to the browser. There we go. Here's the reindeer update. So it's already going through its check here. Now we know this should check out just fine because all we did was change one value. It's not like we changed anything else about the syntax. So let's go into the code and we want to compare and create a pull request for this one. We'll just say, reindeer update, and we'll create a pull request for that. And that will kick off another GitHub Actions, which will check our pull request. And this is probably where you'll find yourself if you're doing this a lot. You already have something that exists. Now it's running a plan against that existing infrastructure. And it's just going to tell you what changes between the existing infrastructure and what the planned change is going to be. So all we have to do is wait for this pull request GitHub action to finish, and we can take a look at what the outputted plan is. And it should finish in a second. There we go. All right. So let's go ahead and expand out the plan and see what the change is. And it's saying Terraform will perform the following actions. And if we scroll down, no surprise, the only change here is the cost center is changing from elves to reindeer. So that's one change. Nothing's being destroyed. So we feel pretty good about this change. What can we do now? We can go ahead and merge the pull request, confirm the merge, and now it's going to kick off the final GitHub action here. I'll go ahead and delete the branch. Gotta keep my branches pruned. I don't want too many. Cool, that branch is deleted. Now it's gonna kick off that final GitHub action over here for this merged pull request that will change the tag from elves to reindeer. So that is now in progress. We can click here to take a look at where we are in the process. It has gone through Terraform apply and boom, it should be done in a matter of seconds because really, what is it doing? It's changing a tag. And I will admit, that's a bit of a farcical example. You wouldn't necessarily go through all this to change the value on one tag, but if you are committed to using infrastructure as code, maybe you would. Maybe that's the best way to do it. So there's a solid log of the whole process and you didn't fat finger anything. Let's go back to the overview of our subnet, and now we can see that the cost center has been changed from elves to reindeer. Awesome. We've gone through a whole CI/CD process with GitHub Actions and Terraform to control our infrastructure in Azure. That's pretty cool, isn't it? Hopefully you've enjoyed this presentation. My name is Ned Bellavance. I'm a Microsoft Azure MVP. I'm also a HashiCorp ambassador and an aficionado of tacos. If you want to buy me a taco, you're more than welcome to. I have a Patreon account. The lowest tier is $2, and that is to feed my ever-growing taco habit. You can also find me on Twitter. I'm Ned1313. My website is nedinthecloud.com. And if you want to check out this example or any other of my examples, they're all available on my GitHub repository. That's Ned1313. Thank you so much and enjoy your holiday season.